Hi, good morning. So today we're looking at question 7 and probably question 8 in this video as well. And it's dealing with calculus. Okay. This is from the Metro Central Common Paper, September 2021. So the first question is, as it normally is in calculus, it's either this or one limits. The question says, determine f prime x from first principles if f of x equals negative 2x squared plus 8. So the formula we use here is f prime x equals the limit as h approaches 0 of f of x plus h minus f of x all over h. Remember, f of x is negative 2x plus squared plus 8. So f of x plus h, wherever I see a x, I'm going to replace it with x plus h. So it's x plus h squared plus 8. Again, I've indicated in question 1, do not say that's x squared plus h squared. Rather, if you're not sure, write it out twice and then you multiply it out. But this will give us x squared times negative 2 is negative 2x squared. X times h times 2 is going to be 2xh times negative 2 is negative 4xh. H squared times negative 2 is negative 2h squared plus 8. Okay? So we do the substitution, we'll have the limit as h approaches 0. F of x plus h is negative 2x squared minus 4xh minus 2h squared plus 8 minus f of x, which is negative 2x squared plus 8 all over h. So we got the limit as h approaches 0. And then we multiply this out. So going to give you 2x squared minus 2x squared cancel, negative 8 plus 8 cancel. So as you can see, we are left with negative 4xh minus h squared. We take out h as a common factor, although negative 2, h is the full common factor here. I don't need that because the reason for me wanting to do that is to get rid of that h in the denominator. Okay? By doing that, wherever I see a h, I can replace it with a 0. So if that goes 0, that falls over. Once I do the substitution into the expression, the limit as h approaches 0 also falls over. So the answer is negative 4x. Okay? In question 7.2, the question says, determine the derivative of the following. Okay, so the common made error here is that what learners do is, okay, firstly that will be 3x. The square or cube. I think it's cube. You just check. It's definitely a cube. Okay. For negative 7 over 2x squared, remember only the x comes up. So it's going to be negative 7 over 2x to the minus 2. Now many learners, what they do is, they take the whole denominator up and then it becomes that way, which is not correct. Remember, we're only going to take the x up. Okay. So it becomes x to the minus 2 plus 4. Now we apply the derivative. So f prime x equals 3 times 3 is 9, minus 1 is 2. Then negative 7 over 2 times negative 2 is positive 7. Remember, the sign must also be multiplied. 7x minus 3. Remember, taking one and derivative of constant is, of course, 0 there. The next sum here, again, binomial square. Okay? Many learners wrote 4x minus 1 over x squared, which is wrong, people. Okay? If you're not sure, write it out twice and multiply it out. But the square the first time is going to be 4x. You got 2 root x times negative 1 over x times 2. That will definitely give you negative 2 over the root of x. So it's going to be negative 2x to the negative half. I'm going to do the long method now as well for you guys. So you can see the multiplication up, and the last term squared is going to be 1 over x squared. Okay? Which then gives us 4x minus 2x minus half plus x minus 2. Very important at this point here. Some people can see they can apply the derivative there, and then they apply the derivative of that in the next step. Do not do that. You can't apply the derivative to part of the expression and not to the other part. Okay, it needs to be done at once in this case. Okay, so say for argument's sake you have written it out twice. This is what you should have seen. So it's the root of x, 2 root x minus 1 over x times 2 root x minus 1 over x. Then we multiply this story out, which gives you 2 times 2 is 4, root x times root x is x, minus 2 root x over x, minus 2 root x over x, plus 1 over x squared. As you can see, those are like terms there. So it will be 4x minus 4 root x over x plus 1 over x squared. Of course, we bring the exponents up, so it will be 4x minus 4. Now, the root of x is x to the half. So x to the half over x to the 1 is going to be x to the minus half. And then we bring x squared out, it becomes x to the minus 2. Which gives you the same answer. Not the same answer. I made a mistake. No problem. The mistake is here. It's supposed to have been 4. Okay? Sorry about that. Now we can apply the derivative. So you say f prime x equals 4. Negative half times negative 4 is positive. 2x, you must subtract 1 from these, minus 3 over 2. Negative 2 times positive 1 is negative 2x minus. That's your answer. Okay? Stay this over here. At any time you can, of course, pause the video. And if you pick up, you made an error, you can redo the question and take it from there. Okay? Let's look at 7.3. In question 7.3, we are given that g of x equals x cubed minus 2x squared plus 3x minus 1. So this is a cubic function. Okay, the question says determine the equation of the tangent to g at x equal to negative 1. Okay, so learners made the error here. When we do this, I'll indicate where they made the mistake. Okay, so very importantly, we need a point of contact. So if this is your cubic function, as you can see, it's positive. The graph is first going up, then down. That's going to be the shape of your graph. Okay. Now, say for argument's sake, I don't say it is. Say for argument's sake, negative 1 lies there on your x. The tangent we're calculating is this tangent. Okay, it could have been here as well, or we could have. I'm just using this as an example. Okay. So this point here is negative 1 in some y value. I need to have that in order to calculate my c value of the equation of for the equation of the straight line. Okay? So by substituting negative 1 into this, we'll get negative 1 cubed minus 2 times negative 1 squared plus 3 times negative 1 minus 1, which gives me negative 1 minus 2 is negative 3, negative 6, negative 7. So this point here is negative 1 and negative 7. That's the point of contact. Okay? That's the first thing we need to do. Then, remember the equation of the tangent is in the form of y is equal to mx plus c. Then we're going to work out g dash of x in pursuit of calculating m, the gradient. So it's going to be 3x squared minus 4x plus 3. We tell ourselves, okay, what does this actually tell us? This is the general gradient of the curve, with the general gradient anywhere along the curve of g of x. But we want the specific gradient or the gradient at negative 1. So we say g dash of negative 1 is equal to 3 into negative 1 squared minus 4 into negative 1 plus 3. That will give you 3. 3 plus 4 is 7, gives you 10. So the gradient at negative 1 is 10. G of negative 1 is 10. Can you see that? So what does that now mean for us? to us. What can be determined from here? We can say that the equation of the straight line is in the form of y is equal to mx plus c. We got m is 10. So y is equal to 10x plus c. To calculate c, you're going to substitute the point of contact, which is -1 and -7. Okay. Remember again, this being your x and a y there. So you got -7 is equal to 10 into -1 plus c. So that is going to give you 3. If I'm not mistaken. So the equation is therefore y is equal to 10x plus 3. Okay, now many times you'll see I'm writing a lot. You can do many steps. You can leave out 1 or 2 or even 3 steps that I've done here on the board. You could have left it out and have done it part in your head. Okay, but because we are accommodating across the board, so if it's an average to weaker learner, they will benefit from us writing so much. Okay, or indicating all these steps in here. Okay, so for the next question, whoops, I need that there. The next question says, determine the value for x, the value of the values for x for which you have x is concave up. So if you look at this here, that's your cubic function, that's the shape of the graph as well. So your concave up and concave down is dependent on the point of inflection. Concavity is dependent on your concave up, or concave down is dependent on the point of inflection. The point of inflection occurs midway between your two turning points, okay? Or it occurs as well as at the point of your second derivative, okay? Is where your second derivative is equal to 0. Now we have dealt with our first derivative before. We dealt with it there. So you must apply the derivative of the derivative, okay? So we apply a derivative there. I then get 6x minus 4. And what do we do with that? We set that equal to 0. Okay, so we get x is equal to 2 over 3. Okay, so the point of inflection occurs at x is equal to this value is x equal to 2 over 3. So it's speaking about concave up. Okay, so if you look at this part of the graph, this part is concave down, and this part is concave up. Okay. What makes that concave up is if I take a ruler, I draw a tangent to this graph. Okay. The graph is going to be, whoops. The graph is going to be above the cubic function. Okay, you see that? The tangent is below. So it's concave up, the graph is above. Okay, anywhere along that curve. Can you see that? It's still up. However, when I come to this part here, the curve is below, so it's concave down there. And if you look at the graph on this side, it's also the curve is below, so it's concave down. So to answer the question, where is it concave up? It's concave up for x is greater than, which is this part of the graph. X is greater than 2/3. Okay. That brings us to the end of question 7. So I'm going to cut the questions for question 8. Okay. Okay, so now we're looking at question 8. In question 8, we are told the graphs of f of x equals negative x cubed plus 3x plus 2 and h of x, which is a straight line, is defined by negative x plus 2 are drawn below. The graphs intersect at P, Q, and has a common y-intercept. Okay, it's not marked there. R is the turning point of f of x. Okay, it's not, you don't have the coordinates there. F of x has the x-intercept at Q and at T. Okay, so I just need to write the equations down. I can just put this up. Okay. So that we can bring that up a bit. Okay. So let's look at the first question. The first question says determine the coordinates of Q. So if you look at what we have here, we have the equation of the straight line and we have the equation of the perpendicular of the cubic function. But since it's a record on, let me just check here. Since it's going to be easier to work with the equation of the straight line. Okay? I'm going to then use H formula. Okay? So for our x-intercept, remember the Q is on the x-axis, so it's x-intercept. We let y equal to 0. X-intercept, let y equal to 0. So h of x, there is your y. So you say 0 is equal to negative x plus 2. So x works out to be 2. I know some of you could have written it down without doing any calculation. No problem with that. Okay. Then in question 8.2 says determine the coordinates of R. So what is R? R is the turning point. How do you calculate turning point? At the turning point, your derivative, your first derivative is equal to 0. So I apply my derivative, f prime x equals negative 3x squared plus 3x. The derivative of a constant, of course, is 0. So what I do is I set that equal to 0. So I drop that. So I divide it by negative 3. I then get x squared minus 1 is equal to 0. So I can go difference of 2 squares. X plus 1, x minus 1. So x plus 1 is equal to 0, x is negative 1, or x equal to 1. Why are there two solutions? Of course, it's 2 points of intersection. And 2 points where the graph turns. Okay, got 2 turning points. But we are interested in this one here. Okay, why? So this is on the positive part of your x-axis. Alright, makes sense? There's another way I could have done this one. Okay, let me first get the R. Then what do I do with this? I substitute 1 back into the original function. F of 1 equals. So it's negative 1 cubed plus 3 times 1 plus 2. It gives you 2 plus 2, which is 4. Therefore, R is going to be 1n. Okay. Of course, there was another way I could have done this part here. You say negative 3x squared plus 3x equals 0. You divide throughout by... I made a mistake, it mustn't be x. No? So, we take the 3 over, so it's negative 3x squared equals negative 3, divided by negative 3 both sides. So x squared is equal to 1, square root thereof. If I introduce square root, plus minus, so x is plus minus 1, which is in turn that. Okay? That is just another way I could have done exactly the same thing. Taking this out, so that's my mistake. Okay. Then in question 8.3, for which values of x is f prime x greater than 0? So if you're looking at f prime x, where's f prime x greater than 0? What does that mean to us? Okay, let's just take this out. Take this off. So f prime x, f dash x, must be greater than 0. So f of f prime x is our gradient. So where is your gradient greater than 0 is where the gradient is positive. So as you can see here, the gradient is negative. We will put a ruler across here, or on this red part here. The gradient will always be negative as the graph is decreasing. Just not at t, no, not at negative. But as it goes in, as it approaches, as it's going to the positive, as x increases, the value of y is increasing again. Okay? At that point, the turning point is 0, so your gradient is 0. And that part the graph is, as x increases, the graph is decreasing. So where f prime x greater than 0 is where the graph is positive, the gradient is positive. The gradient is positive from negative 1 to 1. X is greater than 1, negative 1, but less than. Okay, that is one way. Otherwise, you could have applied your derivative And you could have used your rules of inequalities. Okay, that would have also have worked. In question 8.4, let's scroll this up. In question 8.4, determine the coordinates at which the graph of P, if P of x is equal to f of x plus 2 as a point of inflection. Now if you get something like this here, first we check for the point of inflection on f of x itself. Okay? So the point of inflection happens at the second derivative. So remember the first derivative was defined as negative 3x squared plus 3. The second derivative will occur at negative 6x. What we do is set equal to 0, so x is equal to 0. So your point of inflection actually occurs at the turning point. Okay? So that's going to be 0 and some y value. But we know from here that y value in this case is 2. Not so. So the point of inflection of f of x, again the point of inflection on f of x, on the regional function is 0 and 2, which is this here. Okay? However, p of x is the graph of f of x shifted 2 units in that direction. Can you see that? It's 2 units to the left. If this is positive, it moves to the left. If that is negative, it moves to the right. So if I move that point 2 units to the left, it now becomes, remember the left is affecting my x, negative 2 and 2. So therefore, the point of inflection for p is going to be negative 2 and 2. Let's look at question 5. Get it out. Let's go with the color. The question says determine the possible values of k if f of x equal to k has 2 roots only. So for it to have 2 roots, roots are basically x values, okay? As it's going through here, the roots are, it has 2 roots there, which is on the x-axis bouncing off there, and so it's 2 roots here. So that value is k is equal to 0. If I move it lower here, it will have always 1 root here. As you can see, it's cutting there. Okay, here at this point. Okay. If I move it higher, he's going to have 3 roots. Okay, namely that 1, 2, 3. Okay. If I move it anywhere between the turning points, sorry, I moved the wrong thing. Anywhere between the turning points, we're going to have 3 roots. At that point, it's going to have 2 roots again. Above that, it will have 1 root. So it will have, what's the name of roots here as well, and k is equal to 4. So what's the solution? The solution is where k is equal to 0 or k is equal to 4. Okay, so for question 9, on question 9 we are told that a cylinder with a radius r fits neatly into a sphere with a radius of 10. The volume of a cylinder is defined as pi r squared h. It means area of base times your height there. So the first question says, show that the volume of the cylinder in terms of h can be defined as. Remember that this is given to show that question or prove that question. If that is the case, you cannot use that within the formula, within the proof. Okay? So remember that they're looking at the volume of the cylinder in terms of h. So how do you calculate the volume of a cylinder? It's pi r squared h. Okay? So as if you look at this here, we don't have an r here. Okay? So in other words, we must write r in terms of h first. So where do you find r? There. But if you look at this diagram, that has to stand 90 degrees. And there's going to be 10, so I'm going to apply Pythagoras Amawat. Okay? So, let's just check here again. The volume is equal to 100 pi h minus pi h cubed over 4. Okay, or in terms of h. Okay, so if this is going to be your h here, remember that your h here is going to be r of h. Okay, I think that is where the 4 comes in. So let's check if I'm right here. So it's going to be 10 squared is equal to a half h all squared plus r squared. That is your Pythagorean theorem. Okay? Remember, we want r in terms of h. So r squared is equal to 100 minus a quarter h squared. Okay? So your radius, so that is r squared. I'm going to keep it like that because, as you can see here, there's r squared. And if I'm going to square root that, I'm going to land up to that again. So therefore, v is equal to, let's keep it there, v is equal to pi h, whoops, v is equal to pi h into r squared, which is 100, minus a quarter h squared. So you multiply that up, I get 100 pi h minus h cubed pi over 4. Is that what they want? Yes, that is what they want. Okay, let's look at question 2. Let's go blue. In question 2, we are told calculate the radius of the cylinder. So you must calculate r of the cylinder, correct to 2 decimal places so that the volume is a maximum. The volume is a maximum. So, many times this is the catch. To get it in, to get the volume or the area or the equation out, that at times could be a problem. But 9.2 should never be a problem. Okay? Everybody should pick up this question. Because your 9.2 is dependent on the previous answer that you've calculated. The reason why they give you also this answer here, is besides working towards that, we can actually use that in the next question, even though we haven't proven the previous question correct. Okay, so use that. And it's always a derivative question following this, a maximum or minimum. So I see many people leave that out. It leaves it blank. Don't. Apply the derivative on this. So we're going to say the derivative of the volume with respect to h equals. Okay? This could be written as 100 pi h minus pi over 4h squared. Okay? Is this another way of writing that there? So if I apply my derivative, it's going to be 100 pi minus 3 pi over 4h squared. What do we do with that? We set it equal to 0. Okay? So we take 3 pi over 4h over, it becomes 3 pi over 4h squared equals 100 pi. Okay? So I'm going to move this over. I'm going to pull the calculator in soon. So to get h on its own, I'm going to divide by 3 pi over 4, both sides. 3 pi over 4. And then I'm going to take, so it's h squared is equal to that. And then I take the square root thereof. Okay? So if you're going to do it step by step, it's no problem. The pi's will definitely cancel. Okay? It should cancel, but let's split it with that into the calculator. You can just pull the calculator up. Not that one. Sorry about this now. Some reason or other is not picking it up. It should now, as okay. So if you're putting this in the calculator, it's simply going to be 100 pi. Now some learners get this wrong, okay? If you're getting this continuously wrong, rather put 100 pi divided by, and then you put the second fraction, okay? So it will be 3 pi over 4, which gives us 400 over 3. So you get 400 over 3, and the square root thereof, of course, plus minus. But since we're busy with height here, it can't be negative. It's busy with the length. So it's going to simply be 11,55. Or in the radical form, it's going to be 20 root 3 over 3. Okay. But coming back to the question, what was the question? The question was to calculate your radius. Okay? So to calculate your radius, we have to say that, let me just get the formula from the previous question. We know that the radius squared is equal to 100, so I'm going to write here radius squared is equal to 100 minus quarter h squared. Quarter h squared. Okay? So that is simply going to be 100 minus a quarter h, which is 20 root 3 over 3 squared. Or I could have just written it as 400 over 3. That would have been the same thing. Okay? So r squared works out to be, again on our calculator we go. Say 100 minus a quarter, answer squared, because we have worked out what h was. So it's 200 over 3, 200 over 3, and then we take the square root of that. Okay? The square root of that answer gives us 8,16. Okay? 8,16 centimeters or units or whatever it is given at that point. Okay?